Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning.
So let me start with this question. We have started with discussion last day. We have done a bit of discussion last day. So let's complete the discussion today from scratch again. So what does question number 6 of IIT JMMS 2024 speak about? So it's asking that you're given a continuous random variable x, which is uniform minus 2 comma 3. Now it's transforming the distributions. So understand it's transforming. So it's trying to understand that what is the distribution of this fx, where fx is, you can see they are linear, they are quadratic, and it's a modulus. Okay, so we will understand each of these functions in details. The first part of the discussion has been published on YouTube, on Cheenta's channel, where we have discussed about individual, like what it does to the individual functions. So why mod of x is not uniform 0 comma 3. I will revise that idea, and then I will move on to address in each of these individual ideas, individual functions, and the distribution step by step. Okay, so let's get started. So first one is x follows uniform minus 2 comma 3. This is given, and then we are given the first option is fx is equal to 2x plus 5. The second option is 7 minus 6x. The third option is 3x squared plus 5. And the fourth option is mod x. The question is that how to find the distribution of each of this, whether they're uniform. So it's asked whether they're uniform or not, right? So what should be that process of understanding each of this? Yes, there are shortcuts and stuff. So let's start with the very easy one, the first one, the 2x plus 5. Now, the idea of uniform is that you can understand that if you take like the distribution of minus 2 comma 3, you will see that the distribution will lie kind of, the area is 1/5, the height is 1/5 because the area should be 1, the length is minus 2 to 5, that is 5, so the height therefore will be 1/5, so that the PDF area under the curve is 1, right? The PDF should be like this, the red curve. Okay, so we should ideally expect an uniform distribution to be equally distributed on its support. This is called the support, where it doesn't take any zero values, it takes only non-zero values, whether positive values, because a PDF or a PMF can only take positive values. That was one of the conditions, right? So if x is equal to 2x plus 5, what does it do to the problem? What does it do to the function? So you can understand that, yes, that interval is called support, because that's where the PDF or the f of x, not the f of x, but the PDF or the PMF is, the values are greater than 0. Okay, so that's why that support is called, so that interval is called support. Okay, so let's see how does this change this whole distribution. And for that, always the first step, whenever you're doing transformation of random variables, the first step should always be understanding where the support, how the support is changing. Okay, how the support is essentially changing. That's the first step. Now I'm doing it very slowly, very step by step, so that you learn something after getting out of this discussion. It's very important to me that you understand. so minus 2 comma 3, where does it go after this change? You can understand 2x plus 5 is a linear function, it's bijective. So minus 2 comma 5 should go, it's positive, so it's like nothing is inverted. You understand, if it was a negative function like minus x, if it was minus x, it would have gone to minus 3 comma 2, but here 2x is positive, so it's like kind of everything will be remaining the same. So if you, so you will just see that it will just go to minus 2 into 2, minus 4 plus 5, that is 1 time, and the end point will be 3 3 into 2 plus 5, that is 11. All of you understood this? You can give a thumbs up, because it's a bijective function. Okay, so you can understand it's 1 comma 11. And does it create, does it lead to more enhanced changed change of the PDF? The answer is no. The ideal way to solve this problem is the following: is to write down the changed distribution. You know the Jacobian, right? I mean, you must be knowing the Jacobian, and that's the goal. If you have a random variable x and you change it to, let's say, g of x, then if it has if it has a PDF f of small x, then how will this new PDF change? It's like it will be similar to this f of x, and there should be something like related to the gx, and it has some relation to the derivative of the gx. Okay, how do you find a PDF? So if you want to say, let's say f of x, this is a new random variable, right? So you want to find its, so let's call it this. I will give you one example. Let's call it y. So we want to find the distribution of this random variable y. So we will do probability capital Y less than equal to y. This is the new random variable 2x plus 5. So we will see it's nothing but probability 2x plus 5, because that's a distribution. That's a new random variable. And when you write it down here, you get what? You get probability. You have to return it in terms of x, because you know the distribution of x, right? So x is less than equal to y minus 5 by 2, right? And therefore, you get, now x is a uniform distribution, right? And that's why you need your support now. Why do you need your support? Because you see that where y can be between 1 and 11. So you can see y minus 5 can be, minimum is minus 2. If you put 1 is minus 2, 1, you will get minus 2. And if you put 11, you will get 3. That is, it's correct. That means x should be in that region, right? Because x can take only minus 2 to 3 values. So therefore, this is the correct support you have constructed. And there are more nuances to it. You will see that when you will learn more. Okay, so now this is a uniform distribution, and you know uniform distribution, this is nothing but the PDF, the CDF of y minus 5. And you know how the CDF of an uniform distribution looks like. A CDF of a uniform distribution looks like a straight line from minus 2 to this, right? And therefore you can easily write it down here, and in fact it will turn out to be uniform distribution. You can prove that. Okay, so, and after getting this CDF, you can differentiate it again to get that it will be, okay, let's try to do this. So what will be the PDF of x, capital X, right now? The PDF of capital X, let's digress here a bit. The PDF of capital X, so small fx is nothing but 1 by 5 if x is between minus 2 comma 3, right? So capital fx is what? It's nothing but minus 2 to x f of x dx, right? Got it? Because its support is minus 2 to 3, and you replace it, so it's essentially x minus 2, x plus 2 by 5. Okay, if x is between, x is greater than equal to, is between minus 2 to 3. If it's 0 if x is less than 0, x less than minus 2, and 1 if x greater than 3. But we are only interested in this CDF in this minus 2 comma 3 region, right? So if you replace it here, what will you get? The capital fx is this. If you replace it here, you will get y minus 5 by 2 plus 2, right? Y minus 5 by 2 plus 2 divided by 5. So which turns out to be y minus 1 by 10, right? Y minus 1 by divided by 10. So let's erase this one. And you can understand that y minus y by 10, now if you differentiate it, this is a CDF, right? Now if you differentiate it, you will get this one, you mean on the right hand side. So this is the PDF, right? Did you understand this step? This is the PDF. So CDF is got by integrating PDF, right? Integration of minus 2, that's the minimum possible value it can take the support, to a random point, not a random point, but a variable x, which is greater than equal to minus 2 and less than equal to 3. and it's 1 by 5 dx, right? Because this is f of x. Now if you integrate it, you will get 1 by 5 times what? X minus 2, right? That is x plus 2 by 5. The integration of this gives this. Did you understand? And if anything is less than the support, minus 2, it will be 0, and if it's greater than 3, it will be 1, right? That's the whole purpose.
To book a trial class for your preparation courses of IIT MS, ISIM Stat and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.